In this video, we'll show you how to sketch polynomial functions by hand. We'll be looking at end behavior, intercepts, turning points, and intervals of increasing and decreasing. So the equation that we're given is f of x equals x squared times x minus 3. Notice that this polynomial function is given in factored form. And if I were to multiply through by the x squared, I can see that this polynomial function will be a cubic. The first question says to determine the end behavior of the graph of the function. So that's a really good place to start. If this is an odd function like a cubic with a positive leading coefficient, my right end is going to go up and my left end will go down because they're always opposite. The reason why the right end goes up is because the leading coefficient is positive. Now to find the x and y intercepts of the graph of the function, we are going to look at f of 0. F of 0 is going to give me, to find the y-intercept, we set x equal to 0. So we simplify, and we get that f of 0 is 0. So now I know my y-intercept is 0. To find the x-intercept, I set y equal to 0. And it's good to use the factored form that was originally given, because now I can apply the zero product property, and the only way to get 0 is if x is 0 or if x is 3, so I have two x-intercepts at 0 and 3. Now remember, this is a cubic, so I'm expecting the fundamental theorem of algebra tells me there should be 3 zeros. So one of these must be a double root. Either 0 or 3 must have multiplicity of 2. So what we're going to do to determine the zeros of the function and their multiplicity, zero is the double root because when you look up at the factored form, it's x to the second power. And it will bounce or touch the x-axis at 0. It will cross through the x-axis at 3. So now step number 4 says to use a graphing utility to graph the function. The reason why we're doing that is we want to approximate the turning points of the graph. So in another window, I did type this into Desmos, and I saw that there's a turning point at 2, -4, and in fact it's a relative minimum. So I'm going to take this information and we'll go to a new page. The information that we had, remember, is that the right end is going to go up, the left end is going to go down. We have a y-intercept at 0. We have x-intercepts of 0 and 3. So let's start by noting the right end will go up, the left end will go down. My y and my x-intercepts are graphed. The turning point, which is 2, -4, is now graphed. This graph is going to touch the x-axis at 0, but cross through at 3. Now we're asked to look at the domain. The domain is what are the allowable x values, all real numbers, and all real numbers are allowed in my range. Where is this function increasing? It is increasing from -infinity to 0, and then again from 2 to +infinity. It is decreasing in that little section of the curve from x equals 0 to x equals 2. Notice the notation that I use is not ordered pair notation. This just means decreasing from 0 to 2 along the x-axis. So let's do another example, sketching a polynomial function by hand. This one is in factored form. I know that the right end is going to tend upwards and the left end will tend downwards. If I want to find the y-intercept, I set x equal to 0. So my y-intercept is -8. And I've graphed that. To find my x-intercept, I set the function equal to 0, and then I apply the zero product property. What values of x will result in the function being 0? My x-intercepts will be -4, -1, and 2. So I can graph those points, and they're going to cross at each 0. We have no double roots here, so Next thing that I do is I find my turning point, which again I used a graphing utility to get those. Next year in calculus, you'll be able to find your turning points using a different process. So I'm going to graph those turning points, or just plot the turning points. Now remember, my right end tends up and my left end tends down. And so my curve fits through there nicely. My domain is all real numbers. My range is all real numbers. Where is this curve increasing? From negative infinity to negative 2.73, and then again from 0.73 to positive infinity. It is decreasing for x values of negative 2.72 to 0.73.